Alright class, we're starting a new unit today. We're going to go back over right triangle trig. We're also going to talk about cofunctions today. So right now you could probably pause your screen to get this information down. I'm going to talk through it real quick. First thing is, you should know that the angles of a triangle add up to 180, always. That the biggest side is always across from the biggest angle and vice versa. The smallest which should be across from the smallest side, smallest angle. We'll label the angles with the capital letters at the vertices here. So big A, big B, big C. And then the corresponding side, so that means the side across from it would be like little c, little a, little b. So that's how we know what we're talking about. You also need to remember SOHCAHTOA. I wrote it here and I wrote out what the three are. You also need to remember the other three, secant, cosecant, and cotangent, which means just flip these. And finally, you need to remember your Pythagorean theorem, where c squared is your hypotenuse when it's a right triangle. Well, yeah, we use this for a right triangle, so clearly that's the case. Alright, so anyway, that is that. So here we're going to kind of review how to solve the triangles. So I gave you two triangles, and we need to solve them, which means I want all the information. I want all three sides and all three angles. The first thing I notice is that there are two sides. So right away, I can get little c by using Pythagorean theorem. Now, if you also should just know that one. You get c is 13. So I found little c. Now I need to find angle A and angle B. Here's where we have to use trigonometry. I'm going to use the values that are given to me. So I have this 5 and this 12 and this angle A. If I notice from angle A, 5 is the opposite side and 12 is the adjacent. So I have a tangent situation happening here. So I'm going to just set up it based on what the trig function definition is. So the tangent of A is equal to 5 over 12. So this is where you use your inverse tangent to solve the question. So we'll inverse tangent this side and inverse tangent this side. So you get angle A is equal to tangent inverse of 5/12. And then what you do is you just plug that into your calculator and you get that it's 22.6 degrees. Okay, so now we have angle A is 22.6. Now we need to find angle B. Well, here's what's nice about right triangles. A and B add to 90 because there's also another 90 at C. So you can say that angle B is equal to 90 minus 22.6. And then when you do that, you get 67.4. So angle B is equal to 67.4 degrees. So we have solved all the triangles. So again, we set up we use tangent here to find a missing piece, and you can use trig to find either a missing angle or side, as you'll see in the next problem. So in the next problem, we are missing two sides, and all we have is one angle. But really, we have all three angles, because we also have C as a right triangle. So right away, you guys should be able to say, well, I have two angles, I should be able to have the third angle. Angle B is just 90 minus the 25. Okay, which is 65. Okay, so we have angle B is 65. I'm just going to put that in there. Now I need to find little a and little c. You can pick any angle and any trig function that involves the 8. Well, you can't use SOHCAHTOA at the 90 though, so we're not going to use the 90. I'm going to use the 25. If I use the 25 degrees, this is the adjacent side to a 25 degree angle. And then I want to find the hypotenuse. Let's say I want to find the hypotenuse. So I would say that adjacent hypotenuse is cosine. So the cosine at 25 degrees is equal to 8 over c. When it's in this format, you can switch the c and the cosine 25. Let's say you're not sure how to do this. You multiply both sides by c. So you get c times cosine of 25 equals 8. And then you divide by cosine of 25. So all you have to do is type in 8 divided by cosine of 25. And when you do that, you get that the c length is equal to 8.83. Now to find a, you can use trig, or you can use Pythagorean theorem now. A squared plus 8 squared equals 8.83 squared. So you can do that. Depending on what you use, it might not be as accurate. Like if I'm just using the decimal right now, I would get that A is equal to 3.74 approximately. And again, if you're off by like a hundredth or something, it's not a big deal. So notice how you can set up trig. This is what we set up initially to solve for an unknown. We did it for the angle A, and we did it for side C here. Okay, so that's the thing you're going to practice in your homework. Alright, so complementary angle theorem, it's basically saying what cofunctions are. Sine and cosine are cofunctions since the sine of an angle equals the cosine of 90 minus an angle. And that's why it's called also the complementary angle theorem, because remember, complementary angles add to 90. So if sine is like 20, that sine of 20 is the same thing as cosine of 70. Okay? It also works, so we can show that with the unit circle actually. You guys remembered sine of 30 was 1/2, and that was also cosine at 60. Same thing with the reverse. The sine of 60 on the unit circle was 3/2, and that happens when the cosine is 30. Alright? The other cofunctions then are secant and cosecant and tangent, cotangent. Also cofunctions. Okay? So we can use that to kind of do some identities real fast. If you guys want to pause the screen to finish writing this up, I'm going to move on. Okay? So here's what you do with these. We try to get them to match. So for example, I have tangent of 12 and cotangent of 78. Well, I know that they're cofunctions. So that I know that cotangent of 78 is the same thing as tangent of 90 minus 78. Which actually happens to be the same thing. So I have tangent of 12 minus tangent of 12. Well, if you subtract two things that are the same, you get 0. Here, I know that cosine is sine of 90 minus the angle. So that's sine of 50 over sine of 50. And when you divide something by itself, you get 1. I know that secant is the cofunction of cosecant. I'm not going to write the work now. You guys should notice that 90 minus 35 is 55, so I get cosecant of 55 times cosecant of 55. Now, here, since I'm doing cosecant, it looks like they want me to do an identity, so I'm going to change tangent to cotangent. I want the same angle. I want the 55, so I want to change this one to cotangent of 55 times cotangent of 55. So you end up with this identity. You get cosecant squared of 55 minus cotangent squared of 55. And if you manipulate the 1 plus cotangent squared equals cosecant squared, you would see from your last chapter that that is also 1. Okay. Now, at this point we've done everything for the notes. The homework will also ask you for the 6 trig functions at an angle. That's just doing opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then flipping them to get the other 3. So I didn't put any of those on the notes. I wanted to practice more of the geometry stuff. So again, given this triangle, we're going to answer questions. So again, all it's telling you is that the right angle is at C. That's the important thing. So I'm down here for A and B here. I'm going to draw a quick triangle. It doesn't matter where A and B are, it just matters that C is the right angle. I know that this angle is 10. And I know that B, little b, which is across from B, is 4. Okay, so right away, angle B should be the easiest thing to find because we know angle A and angle C. Angle B is 90 minus angle A. They are cofunctions, believe it or not, in a triangle. When you have a right triangle, these are actually always complementary. So we get angle B is equal to 80 degrees. So I found angle B. This is very similar to the problem I did the second one on the other page. Now I need to find a side, either A or C. I'm going to use 10 again because that was given to me. I'll do cosine again, adjacent over hypotenuse. So I get cosine of 10 degrees equals adjacent over hypotenuse. Now, if you guys remember the math, we multiplied by c and then divided by cosine. It turned into this. I'm going to just skip all that. Okay? And then from there you can just type in 4 divided by cosine of 10, and you get that it's 4.06. So C equals 4.06. So I found C now. So now I can find A. A squared plus 4 squared equals 4.06 squared. Then when you do the math, you get a very small number. You get A is equal to 0.69. Actually 0.70, it rounds up. Okay? And there we go. So use trig to get 1, then Pythagorean theorem, or you can use trig again. Alright, over here, I tell you that I have a triangle, same thing as the one up above. A, B, C is the right angle. I know that C, little c is 6, that's the hypotenuse, and little b is 4. Okay, so the good news here is I can find A by using Pythagorean theorem right away, because I have 2 of the sides. So I get 36 minus 16, it's the square root of 20, so about 4.47. Okay. Now I want to find angle B. And I want to use the 2 numbers that were given to me. So if I'm at angle B, this is opposite, and this is hypotenuse. So I'm going to set up sine of angle B is equal to opposite over hypotenuse. And then remember, you sine inverse both sides, so we get angle B is equal to sine inverse of this. Because remember, that's how we find angles, we use sine inverse. And then when you type that into your calculator, by the way, make sure your calculator's in degree mode. You get 41.8 degrees. And then to get angle A, remember they're complementary, so angle A is equal to 41.8. Actually, that's a lie. It's 90 minus 41.8. Okay. And then you get the 48.2. Okay. So that is angle A. So we've solved the rest of the triangle. Again, this is more of what we did on the front, so you don't have to do these problems. If you want to test yourself, you could have stopped it. Alright, that's it for today. Tomorrow we're going to look at application problems with trig, so it'll help strengthen your SOHCAHTOA.